Hey everyone, we're going to talk about forces and potential energy in this video. Now, I said in a previous video that forces are not really a key topic of this course, and that's true, but we do need to know a little bit about forces for what's going to come next. So let's really briefly do a recap of what a force is, and a few little things that we have to be aware of when we're thinking about them. A force is just a push or a pull. It's not in energy, which is what we've been spending most of our time on in this course. It's, well, a push or pull. Forces can be used to describe some of the same things that we've been thinking about in this course. For example, think about our model of a falling object. The way that we've been thinking about it is that when we drop an object, it's exchanging its gravitational potential energy for kinetic energy. As it falls, its kinetic energy increases while its gravitational potential energy decreases. This is correct. This is an accurate way to describe why an object falls. But we can also think about it in terms of forces. When we drop this object, the force of gravity is pulling downwards on it, causing it to start moving downwards. Again, these descriptions are not mutually exclusive. They're both accurate ways of describing what's happening here. But it turns out that it's more interesting than that. There is a deeper connection between force and potential energy that we want to examine here. When an object has potential energy, it very often also has a force being applied to it. It turns out that this force always points in the direction of decreasing potential energy. Now, what does that mean? Let's unpack that. Again, let's go back to our falling object. The force of gravity is pulling downwards towards the floor on this object. We also know that as the object moves downwards, its gravitational potential energy is decreasing. It's getting closer to the ground. Now, as we saw in DL, it doesn't actually matter what we call the floor when we're talking about gravitational potential energy. But that doesn't impact anything here. Gravitational potential energy always decreases as an object moves down. Similarly, gravity always pulls down on objects. The force of gravity is always in the downwards direction. This is true for any type of potential energy that you can imagine. If you have an object that's experiencing potential energy, it will also be feeling a force in whatever direction would cause that potential energy to decrease. Now, a couple of caveats to be aware of when we're thinking about forces and potential energy. First, just because an object is experiencing a force in a particular direction does not mean it's necessarily going to move in that direction. A force does not override everything we know about what the object is doing. It's only a piece of the story. For example, I can throw this object upwards. As it's traveling upwards, it's still experiencing a force from gravity. Gravity is still pulling it downwards. But it also has kinetic energy. It's also moving upwards because I threw it upwards. But crucially, when I throw it, the only thing it's interacting with is the Earth through gravity. And so as it travels upwards, it slows down and eventually turns around and starts falling. Now, it may not be totally obvious to you why this is interesting. We're really going to start to see how this is useful in the next couple of DLs. Now, gravity is a fairly straightforward example. Again, we're all super familiar with gravity from our everyday life. Gravity is always just pulling us down towards the floor. So let's look at another example that's a little more sophisticated. But to do that, we're going to have to go to the computer. Now, we've seen this simulation a few times before. It's just the simulation of a mass on a spring. If we put a mass on this spring and pull it down, releasing it, it's going to bounce up and down, just as we've seen a bunch of times. Now, in this course, we've typically thought of this in terms of energy. When we pull the spring away from its equilibrium position, the spring is stretched, and that gives it potential energy. When we release it, the spring converts that potential energy into kinetic energy. This just happens back and forth forever, at least in the simulation, not forever in real life. But let's see how we can think of this in terms of forces. The way we can think of this is that the spring applies a force in the direction that will decrease its potential energy. When the spring is stretched, this direction is up because the spring is trying to recompress back to its original length. But what about when we compress it? Well, when we compress it, it's the exact opposite. The direction that the spring wants to go in order to decrease its potential energy is now downwards, and so the mass feels a force downwards from the spring. Now, it turns out that there's a really nice, easy way to write this relationship down. It looks like this. It just says that the force is the negative derivative of potential energy with respect to position. Now, if you don't remember your calculus, that's fine. I'm not going to ask you to take derivatives on an exam, but I do want us to take a minute and think about what this means. Let's just go back to the falling object example. Gravitational potential energy depends on height, and so our position is a height. So what happens if we take the derivative of the potential energy with respect to height? Well, a derivative is just asking how the potential energy is changing. If we take the derivative of gravitational potential energy, we get a positive number. The reason being that as height increases, so does gravitational potential energy. But our equation here has a negative sign on it. This negative sign just means that whatever direction we find that the potential energy is increasing in, we just turn it around and go the other way. Because the derivative of gravitational potential energy is a positive number, this negative sign, well, makes it negative. A negative force in this context points down. Up is the positive direction, down is the negative direction. So if we get a negative force, that's a force pointing down. Exactly what we expect for gravity. Now, you also might be able to see from this discussion why we introduced graphing of energies. You may remember from your calculus class that a derivative also has to do with the slope of a graph. So we know that the negative derivative of potential energy is force, and we also know that a derivative is a slope of a graph, and we've started drawing graphs of potential energy. You can start to see now why this information is useful. You'll see more of it in DL. But there's also a really big topic that we're about to move into that is going to make heavy use of this relationship. We'll see that in the next video. That's all for now. See you next time.